Assalamu alaikum everyone. My name is Taj Muhammad Khan and I will be your instructor for this course called Operating System. So, for starting, I think the most important thing in the student's eyes is the grading. How many quizzes there will be, how many assignments will there be, will there be a midterm, final, what would be the percentages for assignments, quizzes, midterm, final, etc. So in this regard, I am afraid I'll be disappointing you right now. I will not be discussing these things right now, but in a couple of weeks, you will know this information. You know, right now the semester is starting, everything is chaotic because of this online learning stuff, etc. So things are in a state of flux, but they will be clear in the next couple of weeks, hopefully. So this information, I'm afraid you'll have to wait, and we'll discuss it in future classes also. But by the end of the next 2 weeks, I think you will know all this information. So putting your minds to rest, I think for the time being, you should stop worrying about the grading. And right now, why don't focus on learning stuff? So starting. So this is a third year course. I am expecting that most of you will be in your third year. So you need to know certain things for this course. The most important thing that the background knowledge that you need to have is of C programming. I hope most of you or all of you have some exposure to programming, and especially to C or C++ programming, C programming in particular. You should know what are different data types in C, how do conditional statements and loop statements work in C, and how do pointers work. Pointers are very important in C and also in operating systems. So this kind of background knowledge we are expecting for all the students who will be participating in this course. So apart from C programming, I think most of you would have done some course, some low-level course similar to computer architecture or computer organizations, in which you would have seen how does a processor, a CPU works internally, and how do you program it using assembly language. You must have some exposure to some kind of assembly language. This is not required. I mean, you don't have to be master of the computer architecture and assembly language for this course, but still some level of familiarity is needed, because we will be discussing some low-level concepts, which if you don't know about, you will be confused. So either you have some exposure or you catch up during this semester. The C programming is essential. You will need it during your assignments, labs, etc. You will do different programming assignments, and those will be in C programming. Okay, so I hope everybody is familiar with C programming at least, and if somebody is not, they should start working really hard right now and start catch up on this C programming thing. Most of all, what you need is motivation. I hope you guys are curious about what are operating systems, what do they do, and how do they work. And this is the stuff that we'll be learning in this course. And I hope there is some curiosity on your part to find out how things work and how things operate, especially at the lower level. So, equipped with these weapons, you can say, or knowledge, we will start our journey. The book that we'll be using for this course is called Operating Systems 3 Easy Pieces. It's available at this link, which you can see on the slides. And even if you Google OSTEP, I mean, that's the abbreviation for the book, the first link that you'll find, it will be this link, and you can click on it to access the book. So let me show you how does this link, the web page on this link looks like. There you go. I hope you guys can see the web page. So this is the link that's in the slides, and here we have like the book page, Operating Systems 3 Easy Pieces. It's written by Professors Ramsey and Andrea Arpachidisov. I hope I pronounced their names right. They are professors at University of Wisconsin Madison, and I think we are very thankful to them for writing this book because it's a very good book. We'll shortly discuss what's good about this book and making it available free online. So if you scroll down here, here are the contents of this book. So let me zoom in if some of you are having problems visualizing this. So I hope it's clearly visible now. So we can see that this book is divided into different parts. The color coding that you see, this orange, blue, and green parts are the main components of this book. So after introduction, you will see this orange part in 2 columns, which talks about virtualization. Right? So we'll see what virtualization is during the course, but it's just to give you an idea that the structure of the book is divided into 3 main components. That's the 3 easy pieces that they refer to in the title of the book. The first piece is virtualization. The second piece that they talk about is called concurrency. The third one is persistence. We'll see, I mean, if you don't understand what these words mean, don't worry. We'll be discussing them in detail during the course of this course. So there are some chapters on security, etc. So all these chapters, these links are basically links to PDFs of these chapters. Okay, so every chapter is available on this website. Through these links, you can click and download the PDF and then use that PDF to study them. So this is the general table of contents for the book. And then you have lots of other information, other operating system books, which you can read, use as extra materials, okay, reference materials during this course. If you think that the contents in this book are not sufficiently deep enough and you want to further learn about some stuff, these are the books that you will find helpful. And other books that the professors found interesting. Many of you might also find most of these books interesting, but they are extracurricular. So they provide a lot of information about this course, for example, their sample projects, homework, etc., and the news about the latest content that's been added into the book. Some errata that's been corrected and some new chapters that have been added. So this is a page that I would recommend you to bookmark and return to it as frequently as possible, because we'll be following this book, and let me show you what's good about this book. So coming back to the slides. So why did we choose this book? There are other books also that are available. Many have been used for much longer than this book. This book is relatively new in operating systems domain. The first thing that I like about this book is that it's very, very, very student friendly. Other books, they are very pedagogical and aimed at rather experts or undergraduate as well as graduate students. So they cover the topics in a rigorous way, which a completely new beginner might find daunting. So you guys, I think, are being exposed to operating systems the first time, and this course will take it as an introduction to operating system course for you. So for you guys, the other books, they might seem a little obtuse or daunting or too much things at the same time. The good thing about this book is that, as I said, it's very student friendly, and below are the points why I think it's student friendly. First of all, chapters are very short. Every chapter is like about 10 to 15 pages maximum. And the language that is used in those chapters is very casual and informal, which I think is also a plus here, because you guys, you are like completely new, and it's good if somebody talks to you in an informal way, in a friendly way, compared to a professor or a researcher who is talking very formally and stuff. That stuff is also good, but I think at advanced levels, at some advanced level, you will benefit more for that formal tone and rigorous application of the knowledge compared to the stage that you are now. Right now, I think it's very good that they talk very in a friendly manner. So chapters are short and language is very friendly. The examples that they give are also very clear, concise, and small examples which are very easy to understand. That's a big plus because having the right examples can instantly clear the understanding of something which by reading the text you might not be clear about. So in my opinion, that's also a big plus for this book. Other books usually present the theory mostly, and the examples in those books are usually in the exercises that you have to do at the end of the chapter. During the chapter, there are not a lot of very expressive examples. Here we have lots of examples, and the examples are also very short and easy to understand. And the last, that the fact that it's freely available on internet, that's also a big plus. Many operating system books are expensive, and either you spend money to buy them or you resort to tactics like piracy or some other illegal way of accessing them. But here it's freely available and therefore totally legal to download and use anytime. So that's some of the reasons that I chose this book for this course, and I think you guys will also enjoy reading this book. I highly recommend that all of you get to start reading the book. You will have the slides, you will have the videos. They are complementary to the book. They do not exactly replace the book. What I mean, the book is the authentic source for this course. So I urge you to go to that website, start downloading the PDF for these chapters and start reading them. And I'm sure that compared to your other books, you will find this book a breath of fresh air, and you will also enjoy reading this book as much as I did. So that's about the book that we'll be using in this course. Moving forward, let us start the course formally. So just out of from the top of your head, some operating system names that you can think of. I'm sure you know lots of operating systems. You have been in contact with many operating systems. We use them almost daily. I think most of us use operating systems. So just think of some names, and I think if you guys start forwarding the names that you know, you will see that there are lots of operating systems that exist in this world. Even there are like tens or hundreds that are very famous, more famous than others, that we get to see or use in our daily life. So just like every football or cricket teams, there are lots of operating systems and everybody has their favorites. I don't know which operating system you guys have been using. If we were in a physical class, I think now would be a good time to have a poll, a raise of hands. How many of you use Windows? How many of you have used Linux or Unix or some other operating system? Android also, you guys on mobile phones, most of the mobile phones are Android based, or that Apple operating system, iOS, I think, which is used on iPhones. So just this slide shows that there are a lot of operating systems that you have been in contact with. So the question now that we face at the start of this lecture is, what is an operating system? Okay, so this question is further elaborated by 3 sub-questions. First of all, let's start from the basics. When you think of an operating system, what do you think it is? Is it hardware or software? You guys are computer engineering students, so I hope the difference between hardware and software is clear to you. So what is an operating system? Is it some kind of hardware or software? What does it do? What are the main functionalities that an operating system performs? And how does it do it? The first two questions, we'll be avoiding them in this lecture. We'll see that an operating system is a piece of software. By being software means it's just like any program that you guys have written in C, C++, or whatever language you started programming in, but it's slightly different. We'll see how. So it's a piece of software. And what's its job? What does it do? Every program does something. When you wrote your first program, Hello World, I think, what was that program doing? It was displaying a message on the screen. So every program is an answer to solve a problem, and it does something to solve that problem. So which problem is the operating system solving? The program that is an operating system. What does it do? What's its job? We'll study this soon in this lecture. How does it do it? The third question, I'm afraid, is a little longer to answer, and we'll spend the rest of the semester answering these questions, and by the end of the semester, I hope we would have scratched some surface of what an operating system does. So this question, we'll leave it for later, like from the second lecture onwards, and we'll address the first two questions in this lecture. The first question, hardware or software? I already told you that it's a software. It's just like a program, any other program, but special in some ways. What are the ways that makes it different from an operating system, from a normal program? Well, first of all, the operating system software, the program, it's very big. Usually they are big, bigger than your normal programs. Why they are big? Because they have to do lots of stuff. So to let them do this lots of stuff, the guys who wrote that operating system wrote a lot of code. So this lots of code, when it gets compiled, it results in a much bigger program than your normal program. The other thing that's different about operating system is that since it's doing lots of stuff and it does lots of important stuff, lots of complicated stuff, so the program itself is also a little complicated than your average program. Okay? The operating system, it's a big program and it's a complicated program because it's supposed to do different complicated things. We'll see what it does in the answer to the second question. A third way that which makes operating system different from a normal program is that an operating system program interacts very closely with the hardware of your computer. So you need to have some low-level knowledge of how the hardware in a computer works if you hope to understand how an operating system works. Not a lot, but at least some basic knowledge you need to have how a computer works at a low level in hardware. That is what I was referring to when I said that we need to have in the prerequisites, you need to have some low level knowledge of computer organization or assembly language. Not much, just a little familiarity. So the operating system program interacts very closely with the hardware, so it has to manipulate things at a very low level. So the programmers, they wrote some of the operating system code in a very low level approach. So that's another thing that makes an operating system different from your other normal programs, because normal programs, you don't program them at very low level, interacting very closely with the hardware. So these are some of the aspects that makes the operating system program different from your normal programs. Moving on to the second question, what does it do? The operating system program, it's, as I said, very big program, does lots of complicated stuff. But what exactly does it do? We'll see in this future slides. So how does it do it? as I mentioned earlier, we will leave it for the rest of the semester. So where does the operating system program fits in the general scheme of things? So let's say this is our system. You, me, the admin, guest, we are basically the users of this system. We use different programs on this system. Right? These programs could be this Firefox browser, Microsoft Word, VLC Media Player, or the Hello World.exe, the program that we all wrote in our CS11 first semester. So this program, I mean, all these programs, they are called applications, and these applications are run on the computer hardware. Okay, so we know that when we are running these programs are running in some system on some processor, which is soldered on some motherboard, which also has some RAM, random access memory, along with the processor, some connectors to which we have hard disk connected. The other hardware like monitor, keyboard, these devices are also connected to the motherboard. So all these hardware, they combine to form this hardware subsystem on which these are applications run. But these applications, they cannot run directly on the hardware, because as I said, our normal programs that we write, we do not write code that interacts with the hardware directly. So how do we manage to run all these applications on top of our hardware? The answer is with the help of operating system. The operating system, as I said, is a very big program which sits in between our applications and our hardware. So it's operating system that is running directly on the hardware and that talks directly to the hardware. That's what I mentioned in the last slide, that programmers who wrote operating systems have to have knowledge of how an how the hardware of a computer system works, and they have to write low-level code that interacts directly with the hardware. So in their code, they are manipulating this hardware directly. When we wrote our hello world.exe, we did not manipulate any hardware directly. We just wrote a command that print hello world string on the monitor. The monitor, as you can see here, is the hardware. So how does our program, which is running on this CPU, hello world.exe, is running on the CPU? You know from your computer architecture or some other course that any program that is executed on a computer is run inside a CPU. So the program that is running on the CPU, how did it manage to send that string hello world to this monitor? And how did the monitor display it on the screen? So the answer again is that our program, it accesses this hardware or uses this hardware with the help of operating system. So the hello world.exe, which displayed the string hello world on the monitor screen, it requested the operating system to do this job for it. So it could not access the hardware directly because it did not write the code to access the hardware in that program. That would be too complicated for a first semester student. Excuse me. So inside that hello world.exe, when you call that print command, so the print command internally requests the operating system to display that string on the monitor. So the code to that particular, the code to access the monitor, how do you request the operating system and how does the operating system basically displays things on monitor? That is inside that printf command. So here in the operating system, you see the word Linux here. That's because in this course we'll be studying different Unix or Linux-like operating systems, the basic principles of how they work. There are many other operating systems in the world, the most famous example being Windows, but we will not be studying those. We'll be studying Unix, Linux-like operating systems for a couple of reasons at least. First, as you might know, operating systems like Linux and Unix, they are usually open source. Open source means their code is available on internet, the source code. You can go and browse, look at their source code on internet. Secondly, they are usually available for free. If we compare it to the competition, Windows is a closed source operating system, which means the source code is not available to you. Secondly, Windows is paid operating system, which means if you want to use Windows, you have to buy it or buy its license from Microsoft Corporation. Linux and Unix like operating systems, on the other hand, are free and open source. So let's say you want to learn about operating systems. Which would you prefer? An operating system whose source is openly available on internet and you can go and look at the source code to understand how things are implemented and how do they work, or an operating system that is closed source and which only provides you the binary of the program and does not let you look at the source code. So, I hope it's clear that deducing from program binary how does a program does something is much more difficult than looking at the source code, which is usually in C or C++, to see how a thing is implemented and how does it perform its functionality. So that's one advantage of Linux operating system. The other one is also simple to see. On one hand, you have to pay, and on the other hand, you have free stuff. So Linux and Unix are available free to download and implement. So that is why we'll be discussing Linux or Unix-like operating systems in this course. So I hope from this diagram, this is clear that an operating system is the main program that runs on your computer hardware, and it lets other programs, applications run on top of it and makes easier for these applications to access the hardware. The applications usually cannot and do not access the hardware directly. Whenever they want to access some hardware, they have to pass through the operating system to access that particular hardware. So with this in mind, let us answer a couple of questions. What happens when you run your hello world.exe? As I discussed earlier, the hello world.exe is trying to print this string hello world on the screen, monitor screen. But monitor is a piece of hardware and it cannot access the hardware directly. So in order to display something on a monitor, it will have to go through the operating system program. It will have to request the operating system, please display the string on monitor for me. Okay? And the operating system usually will perform this job because it is there to perform this job. So the hello world.exe, it will usually call some operating system code within this printf function. It will call some operating system code, which would go, the operating system code, it would go and talk to the hardware and ask the monitor to display the string, and in response to that operating system request, the monitor or your graphics subsystem will display the string on the monitor. So I hope it's clear that applications do not access the hardware directly, but they access it through the operating system. A second example, what happens when you double click on a film? You see, you have a computer system with a screen and you have some films stored on the computer. When you go into that folder which contains the films, you select a film whose icon you can select and then double click on that icon. When you double click on that icon, a window opens for a media player of your choice or the one installed by default on your system, and the film that was stored in the computer starts running on that media player. You start visualizing the frames of the film on the screen. So again, based on this picture, what happened in a broad overview kind of different steps, what happened from the time when you double click on the film icon and the time that the VLC media player started playing that film. You started seeing the film being played on the screen. So think about it. 2 to 3 main steps, what would have happened between these steps internally. Remember, your film is stored on the hard disk, which is a hardware, and the film is being played on the screen, which is a hardware, and the double click that you did came from the mouse or your trackpad on the laptop, which again is a hardware. So how do these hardware components act, and what's the interplay between hardware and software components that you see on the screen, which results in the film being played? So think about it. That will be the first question that I'll ask you in the next lecture. And meanwhile, try to imagine 3, 4, 5, 6 steps that would happen in the background from double clicking on the mouse and the film being played on the screen. In between, there was some interplay that happened between different components that you can see on the screen, software as well as hardware. And I would like you to have a series of steps that you can see happening between the starting as well as the end point of our actions that achieve the film being played on the screen. So that's your job before the next lecture. So I'll stop here and see you in the next lecture. Thank you very much.